Hey guys, James here, and I'm going to be answering a question, a word problem, on the consecutive odd integers and how to, solve problems like this. I've seen many problems like this before, being a math major and studying and tutoring and teaching all that stuff. And there's one trick that really kind of makes it easy. We have to really just understand the difference between an even and an odd number, what fundamentally makes it like that. We'll get to that in a second. We're going to try to do this the way that most kids would be approaching this problem. 2 times the least of 3 consecutive odd integers exceeds 3 times the greatest by 15. This is going to be a negative answer. How do I know? I'll tell you at the end how I knew. X is the least of them, Y is the middle of them, Z is the greatest. We're just defining our variables, and we're going to set up our equation. So 2 times the least of the 3, so 2 times X, exceeds 3 times the greatest by 15. So that means that 2 times X is bigger than 3 times the greatest. So I need to add 15 to 3 times the greatest. 2X equals 15 plus 3Z. But that's all it says. That's all I have. I have 2 variables and only one equation. I can't solve that. I don't have enough information. But I do. The information is hidden right here. Consecutive odd integers. That's a lot. That means that gives us very specific parameters to work with. So if we go ahead and uncover this, even versus odd, what makes a number even? It needs to have a factor of 2. It needs to be divisible by 2. Evenly divisible by 2. So even numbers are multiples of 2. We can write them as 2 times n, where n is any integer. What's an integer? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, blah, blah, blah. You should know what an integer is if you're having to do this problem. Now, what is an odd number? I gave it away a little too quickly, but an odd number is a non-even number. And after every even number, if we, adding 1 to it brings us to the next number, which is always odd. So if we have an even number, 2n, where n is an integer, I should have included that there too. An odd number can be written as 2n plus 1. So I've kind of set up this problem that I'm actually going to do. Then I'll talk about that other one later. Because I'm not going to do your homework for you. You get to do your homework. So 2 times the greatest of 3 consecutive odd integers is 1 fewer than 3 times the least. What is the product of those 3 integers? Okay. So I've set up the equation like we did before, but we have 3 variables. One of them's not even in here. 2 of them in one equation we can't solve. So we need to find a way to relate all 3 of these numbers to each other. Well, we know that they're all odd numbers. So let's write x as 2n plus 1, where n is an integer. Now, how do I get to the next consecutive odd number? Well, what's consecutive mean? It's the next one. So if I have 3 is x, then the next one will be 5. And if 5 were x, the next one would be 7. If 11 was x, the next one would be 13. What's the pattern there? The next consecutive odd integer is going to be 2 bigger. So I add 2 to 2n plus 1, and I get 2n plus 3. Z, the biggest one, is going to be 2 bigger than the middle one, 2n plus 5. So I have now related x and z to the same integer, and I'm going to be able to plug these in for these values in this equation and solve. So let's do that. Let's put in 2n plus 1, copy. Grab this, grab x, put some parentheses, and plug. Always put parentheses when you plug. It prevents a lot of errors. I'm going to put this in place of z, parentheses, copy, paste. There we go. So we now have this equation. Move this guy out of the way. And we will look at our equation. 2 times 2n plus 5 plus 1 equals 3 times 2n plus 1. So let's distribute. 2 times 2n, ooh, that's perfect. 2 times 2n is going to give us 4n. 2 times 5, and then we're going to also distribute over here. I'm going to type it out because it looks way nicer. 4n plus 2 times 5, which is 10, plus 1 equals 3 times 2n, gives us 6n plus 3. So let's solve. We then have 4n plus 11 equals 6n plus 3. If we subtract 3 on both sides and subtract 4n on both sides, we will have all of our n's on one side and all of our constants. So we have 11 minus 3, that's 8. And we have 2n over here. Then we need to divide both sides by 2, and we get n equals 4. I was almost done here. So now we know n equals 4. We're done, right? That's the answer. N is even, though. What happened? Well, those aren't the numbers we're looking at. We're relating n back to our numbers that are in the answer. So x is 2 times 4 plus 1, which is equal to 9. The next number is the next consecutive even integer, and the next one is the next consecutive even integer. So 9, 11, and 13 is the answer to this question. Real quick, I'll go back to this one, talk about how I knew it was negative. 2 times the smallest number it exceeds 3 times the biggest number. So I have this biggest one. I multiply it by a bigger number than I'm multiplying the smallest one by. I'm going to get a bigger number. Has to be negative, because with positive numbers, with integers, well, any positive numbers just doesn't work. Bigger times bigger is bigger if it's all positive, but that's not the case here. Anyway, that's it for me. I hope this helps you, and yeah, that's it. You can finish this one out on your own. You're going to set it up just like I did this one here. Have a great day.